guys, today I am going to explain about Bandgap of semiconductor materials. Okay, so we know about materials, right? So materials can be classified into three different types based on the electrical conductivity, right? So based on electrical conductivity, it has three different types. What are the three different types? Conductors, semiconductors and insulators. So we have three different types of materials based on electrical conductivity, right? So conductor, it has good conductivity of electricity. So insulator, it doesn't conduct electricity, right? So but semiconductor, it has both conductors as well as insulator. Okay. So then what is semiconductor?
Semiconductor is a conducting material. It acts as both insulator and conducting material. When temperature increases, semiconductor behaves as a conductor. When temperature decreases, semiconductor behaves as an insulator.
Okay, very good. So on 0 Kelvin, it begins as the insulating material, but increasing temperature, conductivity also rises. Okay. So what are the properties of semiconductors?
At 0 Kelvin, it acts as an insulator, while at temperature is increasing, it acts as a conductor.
Okay, at 0 Kelvin, it acts as insulator, increasing temperature, it acts as conductors. Okay. So while increasing temperature and the temperature rises, the conductivity also rises. So temperature is directly proportional to conductivity. Okay, right? So here the resistivity is inversely proportional to the temperature. While increasing temperature, resistivity increases, whereas the conductivity will be increases, right? So in conductors, we have two charge carriers. One is electrons and the holes. Okay. So at 0 Kelvin, it has only filled valence band and empty condenser band. While increasing temperature, the ground state atoms exceed into conduction band, whereas the conductivity is increases, right? Okay. What are the applications of semiconductors?
The applications of semiconductors are diode, transistor, IC, solar cells, and LEDs.
Okay, we have enormous applications, right? So, okay, come here. So, actually, in semiconductors, we have two energy bands, right? One is valence band, another one is conduction band. So, valence band and conduction band. Right? At 0 Kelvin, so the semiconductor acts as insulator, right? While increasing temperature, it behaves as conductor. Conductivity rises, right? Okay. So at 0 Kelvin, it has filled valence band. All the electrons are filled at valence band, right? Okay, so at 0 Kelvin it has filled valence band. So while increasing temperature, the ground state atoms will absorb the energy and rises to conduction band. Okay, at that time the conductivity also increases, right? So the electron goes to conduction band, whereas it has created holes here. Okay, so again the semiconductors are divided into two different types. What are the two different types? Intrinsic semiconductor and extrinsic semiconductor and extrinsic semiconductor, right? So intrinsic is nothing but the purest form of semiconductor. It doesn't have any impurities. Okay. So for example, silicon and germanium. So these are all the pure form of semiconductors. So it is called as intrinsic semiconductor, right? So in intrinsic semiconductors, let us consider a silicon wafer. It consists of only silicon atoms, right? So whereas the extrinsic semiconductor, so here it has to be added or doped with impurities. Okay, so what is meant by impurities? So we have added the another atom. Okay, right? So based on impurity, the extrinsic again divided into two different types, P type and N type, right? So in P type semiconductor, we have added trivalent impurity. So what is meant by trivalent impurity? In its outermost orbit has 3 valence electrons. Okay. In N-type semiconductor, we have added pentavalent impurity. So which type impurity? Pentavalent. So in pentavalent impurity means in its outermost orbit it has 5 valence electrons. So because of the pentavalent impurity, so here in N-type semiconductor, the majority will be electrons. In n-type semiconductor, majority will be electrons. In p-type semiconductor, the majority will be. So here majority will be, here we have added trivalent impurity, so that the here majority will be holes, right? So in n-type we have added pentavalent impurity, so that it has majority charge carriers electrons and a minority charge carriers holes, right? So in p-type semiconductor we have a trivalent impurity, so that it has majority holes, the minority will be electrons. Okay, that's all. So these are all of the semiconductors and its introduction. Okay, right? Thank you. So listen, so we have so in this class I am going to explain about band gap of semiconductor diode, right? So what is meant by band gap? So band gap is nothing but so the gap between valence band and the conduction band. That's all. Thank you all.